Hello everyone, and welcome to CSCI 343, Fundamentals of Data Science. And I'm coming to you today physically from my home office, virtually from this awesome lecture hall. As you can see, we have a full crowd of poster board people out here in the audience. I hope they're enjoying today's presentation as much as you folks will be watching this in the future. Anyway, so moving right along, we're going to talk a little bit about our syllabus. And first element is, of course, well, me. I'm your instructor. I'm Dr. Adam Jones. Uh, you're going to be seeing me virtually in this format on a weekly basis. You can also see me on video during my office hours. I'm going to be having online office hours. The scheduled office hours are Tuesday, Thursday from 10:30 to 1 p.m., but I'm freely available a lot of times outside of that. So if you need to get in touch with me, please send me an email and we'll set up a time that'll be dedicated specifically to you. So these open office hours that I've got listed on the slide here are for everyone. So anyone can walk into them. It's first come, first serve. I usually try to keep walk-ins to about 20 minutes each so we can make time for other people to come in. But if you email me ahead of time and schedule some time to talk, that time will be dedicated specifically for you. So at the bottom of the slide here, you see a large yellow box. This has the link to my website on it. If you go there, here is how you get to my office hours. There's a giant blue button. And this giant blue button says Connect to Dr. Jones's Skype office hours. You click on that. It'll ask you for your official University of Mississippi email address. Enter that, and you'll be automatically connected to me on video. Now, the scripts that I use to make this do rely on Skype as opposed to Zoom or something like that. But Skype's free, and it's really easy to use. So it shouldn't be too alien to any of you. It's pretty intuitive. It's actually been around a pretty long time, so you've probably used it at some point or another. Okay, our helper this semester is a graduate student, Riley. Riley is your go-to man if you have any trouble, any questions in this class. He's a graduate student in computer science. He's been around, he's seen stuff, and he knows how to fix problems, specifically your problems. So the chain of command in the class is if you ever have any trouble, check your notes first. This is always your first line of defense. Check your notes. After that, we have an excellent course wiki. So go to the course webpage, go to the course wiki, and there's lots of notes that I've written for you that should help you through any of the topics. If you're still having trouble, talk with Riley. Riley works through all of the problems that you're going to be doing in this class, so he knows the kind of issues you should be encountering. And if you've encountered a problem that Riley can't solve, well, then you've got big problems. And when you get big problems, you call in the big guns. This guy. So once you've exhausted all of your resources, you can get in touch with me, and I'll try to help you out as best I can. Usually, the problems that you encounter in this class aren't going to be too daunting. They're all tractable. As a matter of fact, all of the assignments that I'm going to give you in here, I've personally done myself. And sort of my rule of thumb is if I can do them in 20 minutes, you should be able to do them in 2 weeks. So I actually try to keep it, as reasonable and fair as possible for you guys. Normally, we would be meeting in a physical classroom in this wonderful building. But, as you can see, we're meeting online, virtually. We've already had our first meeting. And in that first meeting, we essentially went over the same material we're going over today. But I know some of you weren't able to be there for that, so I'm doing my virtual version of this as well. And man, it is weird and confusing having 40 people in a Zoom session. Hey, but somehow you guys made it work. Believe me, I didn't. Yeah, I was just yammering at you folks. But you were all excellent students, very polite, and especially when we got disconnected a couple of times. Darn internet. Thank you for being patient with me on that. So this is the book that we're using in the class. Data Science from Scratch by Joel Gruz. There is a first edition and a second edition of this book. The main difference between them is the first edition focuses on using Python 2.7, while the second edition focuses on using Python 3. Python 2.7 has reached end of life, so really it's probably better if you get the second edition and utilize Python 3. But for your assignments in here, I really don't care if you use 2.7 or 3 as long as you turn in a working assignment. This class focuses on getting things done. I am interested in the results that you're going to produce. And I'm not going to nitpick a lot of the minutia about how you got it done. For instance, if you use Python 2.7 or Python 3, or if you used Python on Linux or Python on Mac or WSL or Anaconda or anything like that. This class focuses on getting stuff done. And so does this book. It's fundamentals. It starts from implementing a lot of these things from the ground up, which is what I want you guys to learn. Also, it's kind of cool. I don't know if computer scientists anymore do this, but back in my day, we like to keep an O'Reilly zoo. So, you'd walk into someone's office and, you'd have a bit, you could see the distinctive O'Reilly covers on their shelf, each of which, represented by an animal for each topic. Goodness, the old days. So, in order to be in this class, you need to have at least these minimum requirements, 111, 203, 251, or 256. The physical requirements you're going to need is access to a computer capable of running at least Python 2.7. You'll need to install NumPy, SciPy, Python image library, or Pillow, either one of those, and Matplotlib. If you don't know what I'm talking about, that's okay. And here's why it's okay. If you go to the class website, at the bottom of the page, there's some helpful links. One of those helpful links is installation instructions for Python. And it's actually very detailed. I've written out some instructions for getting Python installed on Mac, on Windows. If you're using Linux, 1, you probably already have it installed. 2, you know how to get it done. Yeah, if you have any issues or troubles with getting it installed, talk to Riley, talk to me. We'll help you out in that regard. But the instructions on the website are actually pretty clear. Really, the easiest way to get Python installed on your machine, if you're a Windows user, that is to use Anaconda. Anaconda is super straightforward, is going to include all the libraries that you're going to need for the assignments that we're giving in this class. So, well, as we talked about already, this class is being taught remotely. There's going to be a combination of both pre-recorded material and live stuff. The live stuff is mostly going to be relegated to discussion sessions, question-answer sessions. I do live coding events, so a lot of you are coming in here with not a lot of Python experience, and that's okay. Python looks like just about every other programming language you've probably seen, with a few minor exceptions. So we are going to have some live coding events to work past, some of the hitting the ground running kind of issues. Now, I really, really love the picture over here. This is just one of the best old school retro futurism kind of things that you can kind of point to. It's and the thing is, this is real technology. This is a dude with a mobile computer connecting to some remote network using a payphone, like really, really old school modems. I never used one like this, but I used to troubleshoot real modems back in the day as a high school job at a service provider, and it was the best. You learn how to diagnose things by ear, just listening to the grunts and beeps that the modem's making, dong dong. There's a small group of people out there who may be watching this who just realized that, oh my gosh, that is exactly what a V90 modem used to sound like back in the day, specifically a USR V90. Anyway, moving on. The grading in this class is a little bit different than what you might have experienced before. We use experience points. I actually don't particularly like the way that a lot of classes are graded. You come in on day 1 with 100% of all of the stuff done. And so your grade, technically, on the first day of class is 100%. You have an A. The only place to go is down. Well, I don't like this philosophy. Personally, the philosophy I like is you come in on day 1 with no experience whatsoever, 0 points. And the only place for you to go from here is up. So you earn experience points over the course of the class. There are 3 different ways to earn experience points. The first of these ways is programming assignments. You're going to have probably around 6 programming assignments throughout the course of the semester. We're having to adjust our time scale a little bit, 1, because we're online, 2, because it is a shortened semester as well. But I believe looking at how the schedule's going, we can get 6 assignments in there. Um, so programming assignments are worth 250 experience points each. 200 of those points come from getting your assignment working. Those first 200 points are based not on whether or not your assignment works, because guess what? Your assignment has to work in order for you to turn it in. Those points are assigned to you based on how quickly you come to a solution. Like I said, I actually do all of the assignments that I give you in here. And like I said, if I can do them in 20 minutes, you should be able to do them in a 2-week period. So, if you turn them in on the first day of your submission window, there's no due dates in here, there's submission windows. On the first day of the submission window, you get all 200 points. Second day of the submission window, you lose 20 points, 20 points, 20 points, until there are no more points left to lose. Even if you don't turn in the assignment within the time period that will actually award you submission points, remember, there's 250 points, and we just talked about where 200 of them come from. 50 of those points just come from you uploading the assignment properly. So no matter what happens, no matter how sideways your project goes, before the end of the semester, upload the attempt that you made, your good faith attempt at actually doing your assignment. And you'll be able to get up to 50 points on that assignment. There's no reason not to do this. You're always going to get some points if you make a good faith effort at submitting your assignments. Okay, so that's the primary place you're going to be getting points in this class. The other place you're going to be getting points is from quizzes. We have a quiz alternating weeks from assignments. So every 2 weeks we have a quiz. And that quiz is worth 100 experience points. These aren't going to be... The quizzes aren't there in order to make you do worse in this class. They're there to remind you of things and keep you studying and thinking about the topic. So they're not going to be anything terribly mind-blowing. I seldom actually ask for snippets of code. I want to know what you think and what you know and what you remember about the topics we covered. And I'm only going to ask you for a formula once in the entire semester, okay? And I'll let you know when that's coming. And by God, when that quiz comes around that asks for the one formula I'm going to ask about all semester, you better get it right, because I told you on day 1, I'm going to ask you for one formula on the quizzes. Otherwise, the quizzes are usually focused on more practical aspects of the lecture and the material. Excuse me. Okay, so the third place that you can get points are bonus assignments. We don't have a lot of bonus assignments, but we do have them. Bonus assignments usually get you a small number of points. There will be one bonus assignment that will give you a large number of points that will make up for perhaps turning in an assignment very late, or maybe bombing a quiz or something along those lines. So bonus assignments are optional. You don't have to do them. I recommend you do them. And if you've ever been in the situation where at the end of the semester you looked at your grade and you thought, man, if I had a couple more points, I might have a letter grade higher. If that thought has ever crossed your mind, for the love of all that is good, do the bonus assignments. Because once they're passed, you can't go back and get them again. And most of the bonus assignments come in the first 2/3 of the semester. As it gets towards the end of the semester, we're getting down to the nitty-gritty and we're doing really hard assignments. So you want to get those bonus points in as early as possible. Okay. So, yeah, I've actually just... This was the whole spiel about the assignment. So we're going to have a lot of assignments in the class, usually on a 2-week rotation. Again, we're going to have quizzes, and you're going to need to study for these guys. So I pretty much powered through these 3 slides, sitting back there on the experience point slide. Anyway, I do have to verify attendance. One of the the things about working in a university is there are bureaucratic checklists that you have to deal with. One of them that I have to deal with at the beginning of every semester is attendance verification. I have to go in and I have to click a box that says you attended class in those first 2 weeks. That's a little bit difficult to verify when we're doing stuff online like this. If we're in person, we could call roll, or I could hand out a sign-up sheet or something like that, and we could get some indication that you were actually in the class. More difficult to do online. So, how I'm doing this is you already have a quiz posted on Blackboard right now. It's really more of a survey, but I'm counting it as a quiz. So I'm throwing you a softball during the first week of class. This quiz is how I'm going to verify that you actually attended. So the quiz that I've got posted up there right now is a technology survey. It's asking what kind of computers, cell phones, if you got VR headsets or something like that, that you have. So I want to know what technology you have access to so we can better tailor the experience of this class to what is available. So please go out there and do that as soon as you can. As a matter of fact, it's due before 11:55 p.m. on Friday. Most of you already submitted this assignment before we even met, so that was awesome. Now, here's the thing that I don't like to talk about: academic honesty. I don't like to talk about it because it's not important. I don't like to talk about it because we have to talk about it at all. So, here's the thing. I'm a computer science PhD. I did my undergraduate in computer science. I've been around. I've been on the student side of things. I've seen students do stuff. Never done it personally myself, but I know that it is easy to cheat in a computer science class. It's so easy because there's so much material out there, and it's tempting to go and Google something and find an exact solution to a problem and then use that for your submission. It's quick, it's easy, and if you go in and you rename some variables, you move around some lines of code that might not be order dependent, rename some variables, change some indentation, things like that. It's easy to trick a TA or someone who might be looking at your code sort of with a cursory glance to see if it was copied from somewhere. And same goes for duplicating code from someone else in a class. You could apply those same characteristics or those same tactics and maybe easily fool a human. Now here's the thing. This is a data science class. We do data analysis. We analyze stuff. And guess what? Your programs can be broken down into a tree-like structure that can be analyzed, independent of comments, independent of variable naming schemes, independent of white spacing. What we can do is we can actually feed your programs, and we do, feed your programs to an AI. This is a black box system called MOS. Look it up. You can go and, challenge yourself to try to crack it if you want. If you crack it and you can beat me on it, fine. You learned something by doing that I am not capable of teaching you in this class. Matter of fact, you probably solved a data science problem that's harder to solve than what you're going to face in this class. So the easy solution is to just do your work. Because let me tell you, the software similarity checker is scary good. Sadly, people take me up on this challenge every semester. And let me just say, more often than not, those who decide to challenge the software similarity checker, MOS, usually aren't probably gonna be on the side of the programming spectrum that would be able to beat it in the first place. So it'll save you a lot of heartache and me a lot of frustration if you just do your assignment. And here's the thing. If you decide to submit code that's been duplicated, you're more than likely going to get caught. It pops out in the data every time. The really neat thing is, since you are working on similar projects, there's going to be what's called background similarity. So there's going to be a certain similarity across the board. Usually, 30% or less. But When you duplicate code, that suddenly jumps up to 70, 80, sometimes 90, 98, 99%. And those are not coincidences. Over the lifetime of the universe, it's statistically improbable, down to like 0.0000001%, and really there's probably a lot more zeros in there. Likely that you would end up randomly with a piece of code that's that similar to someone else's. So over the history of the universe, it'll probably happen. Over the history of this class, and even my lifetime, it's a statistical, it's practically statistically certain that it would not happen. So just do your work. That's mostly what I'm going to say there. If you do get caught, I'm required to report you every time. However, I'm not going to confront you on it. I'm going to show you the data, show the data to the whole class, and like, hey, you know who you are, you know you duplicated, you know you cheated, come talk to me. If you talk to me and fess up, I'll often show a little bit of leniency. You're still going to get reported one way or the other, but you might not make a 0 on the assignment. I don't want you to get kicked out of here. I want you to learn stuff. And here's the thing. Everyone makes mistakes. And when you make a big mistake, that's a big opportunity to learn. But you have to fess up to it. So, yeah, there's my spiel for today on cheating. Sadly, I have an entire lecture dedicated to this topic that I'll probably have to give during the semester. I don't want to, and hopefully I won't have to. Hopefully this will be the last time you hear from me on this topic. If you're in need of any kind of academic accommodations, please go through Student Disability Services. I used to get like a notarized, like stamped kind of letter in order to, do accommodations. It's all digital right now, so I've got to get like the official email. So if you need accommodations for this class, please go through Student Disability Services so I can have that official email and get everything lined up. Okay, so my goals for this class. Primary, number one, my goal is to make you guys data scientists. I want to get the fundamentals of doing visual analysis and some basic statistical analysis into your heads. In doing this, we're going to be covering a lot of fundamentals. So we're going to be looking at some really basic stuff and building up from there, which is good. For those of you who are not computer science majors who are taking this class, who might not be, at least in your mind, like expert programmers, you're probably better than you think, by the way. But if you don't think you're an expert programmer and you're a little bit worried about this class, don't worry. We're going to start with fundamentals and build up from there. Over the course of the semester, we're going to continue accelerating. And by the end of the semester, you're all going to be writing neural networks, and that is pretty darn awesome. So don't be scared. Just come at it with an open mind, and we're all going to have fun. So you're going to need to collect lecture data during this class. Please, please, please don't neglect to take notes about what we talk about. I know a lot of this is going to be recorded, but it's going to help you remember the material if you choose to write down this stuff and actually take notes. Especially if you see something like, you know what, that seems important, but it's the kind of thing I'm usually going to forget. Write it down. Okay, so in order to be in here, you've all had to have some sort of Python programming class. Or had some programming class, not necessarily Python. Otherwise, you wouldn't have been able to register for the class. If for some reason you snuck in here without having to get one of the intro programming classes, please let me know, because that's a mistake. But as long as you've had some sort of intro programming class, you're probably going to do okay in here. Python is different in some ways than a lot of other programming languages, but it's also more similar to other programming languages than it is different. But the important thing for me to mention here is this is not, by any stretch of the imagination, a class on learning Python. This is a class on using Python to do data science. So we're not going to teach you how to do Python. We're going to have a couple lectures where we talk about the basics of Python, but those are going to be very rudimentary introductions. it's not going to be difficult to catch on, especially since you have had programming languages before. But in order to catch on, what you're going to need to do is actually work through the examples I show you in class. The slides that I'm presenting in these lectures are going to be posted to Blackboard. Any code that I do or talk about is going to be copy and pastable at the end of the lecture slides. So just go to the end of the slides and you can copy and paste those. You can manipulate them. You can do them from try to do them from memory if you want. Just practice with the code so that you learn those basics of Python. And again, like I said before, I don't really care what development environment you use. You can use Anaconda, WSL. You can do it in Cygwin, MacPorts, Homebrew. Someone in our live version of this mentioned using I think it's like Google Colab or something like that, an online IDE of some sort. I personally haven't used it, but anything that works is going to be a viable way to do your assignments. I'm not going to nitpick the way that you do this, as long as you're the one who wrote the code and you got it working. I'm also going to provide some easy bake solutions. These are Python snippets that can be easily adjusted to do a lot of different things for a lot of different purposes, and that you're probably going to end up using a lot over the course of this semester. Okay, so the course has a wiki page. If you go to this address up here, it will bring you to that. It's got the syllabus information, and it's got a list of topics. The list of topics are all linked. If you click on them, it will bring you to a wiki page with notes on that topic. Actually, the first couple of topics don't have notes associated with them because they're going to be pretty straightforward and covered in the lecture. But when we start getting to the more challenging topics, those have individual note pages associated with them. So definitely check those out. If we have to add anything else, they're going to be added over the course of the semester. And also, as I mentioned before, the instructions for installing Python are going to be at the bottom of the wiki page. So check it out. And one note here, like I said, Anaconda is the easiest environment for you to use if you're a Windows user anyway. But if you're a computer science major, I actually strongly encourage you to use like Cygwin or WSL if you're in Windows, so you get that Unix, Linuxy kind of experience in developing. It's a very good skill to have. Okay, so for your assignments, you're going to be assigned a spirit animal. So this spirit animal is going to be an ID that you use to log into the website to download your individual data set. Each student in this class has their own personal data set. Like I said, it's a data science class, so some of this data is going to be generated specifically for you. So every student has a random and different data set with certain characteristics in it. Other times, you're all going to be using the same base data set, but it'll be digitally fingerprinted so that I know that this data set was for this student, this data set was for this student. So be sure that when you do your assignments, you're using the data set that is for your specific user ID. Okay, so the quiz on Blackboard. I just went ahead and plotted a little bit of the data that we had. I think, most of the class had submitted at this point, and this is the programming experience as reported by you guys. So most of the class, over 50%, identify themselves as being middle-of-the-road programmers, so average. And there's a long tail out towards less experienced. And like I said, that's okay. Over the course of this semester, we're going to be focusing on fundamentals, and applying those to data science. So even if you're not the strongest programmer, you've still got more than a fighting chance in here, so don't be scared. But to go ahead and do this quiz on Blackboard at your earliest convenience, definitely before 11:55 p.m. on Friday. Okay, so this is, of course, a data science class, and you get it, data and science. I actually really love both of these pictures here. One, because I'm a huge Star Trek dork. I freaking love Star Trek. And two, this guy, just look at the look on that man's face. I don't know what he's doing, But just by the sheer look on his face, you can see that he believes he is doing science. And then the cat up there at the top, it's like looking at you like, I'm Batcat. Anyway, that joke really works well in the classroom when there's people. When there's just a bunch of cardboard cutouts staring at you in this virtual classroom and no one's laughing, it feels a little creepy. But yeah, it's haha, made a joke. So, but first, let's talk about science. This would normally be the part of the lecture where I look out at you and say, okay, no wrong answers. What is your definition of science? What have you been taught is science? And you get a lot of different answers. One of the common but somewhat cavalier answers you'll get is is that science is reality. Dramatic pause. Well, not really. Science is not reality. Science is a mechanism for approximating reality. Science is a toolbox that we use to better understand the universe that we live in. Science, if you want to think of it sort of in the mathematical terms, is the limit approaching reality. One of the things we're going to talk about in here is there are no complete theories. Everything has a hole in it. Everything is an approximation approaching some ideal that exists in nature, and science is no different. Science is our means of approximating reality, or the limit approaching reality. So for the purposes of this class, if you don't get anything out of here, remember that one thing. Science is our means of approximating reality. That means, if you think about it, that some of the things that we see as science fact today won't be science fact in the future. And this is how science works. Science evolves and develops, and when we find out new things that are more accurate and better models of the things that we thought we knew, we discard those things and replace them with the new things. Science is a continuously refining approximation of reality. So keep that in mind, and for the purposes of this class, that is the definition of science. Science is our best approximation of reality, our limit approaching reality, our mechanism for better approximating this universe that we live in. Okay, how about data? Well, I usually do the same thing. I ask the class, tell me what's data? And of course I'll have someone say, it's ones and zeros, man. No, it's not ones and zeros. Get out of my classroom. That is like the most inappropriate answer possible for what is data. Ones and zeros, we like to think in binary as, computer people. But ones and zeros is a representation of data. Now, data is an echo of our surroundings. Ones and zeros are an encoding of one of those echoes. It's a representation of something else. Data is an indirect representation of a thing. Now, that thing might physically exist. It might be like the physical table that's in front of me in my room that you can't see. Or it could be the virtual representation of this lectern. But it's a representation of something else. So data can often be thought of as an echo of something else. And just like with an echo, all of our measurements of anything is indirect and is going through multiple layers of distortion before we actually finally record it. So for instance, actually, I want to skip to this slide. For instance, if we look at this, and I ask you what this is, if you're a smart, astute student, you'll say, this is data. And you're right, but let's talk more pragmatically. When you look at this, what do you see? Some folks say they see a dinosaur. And of course, then I would say, well, no, you're actually not seeing a dinosaur. Then someone who thinks they're a little bit smarter than the rest will then say, it's a dinosaur skeleton. You're getting closer, but you're still not quite there. Then someone will say, oh, well, it's fossils. because it's not bones anymore. The bones have long since decayed away and have been replaced by sediment. And we have this essentially like almost a ceramic version of a dinosaur now, or rather a ceramic version of a dinosaur skeleton. And you're getting closer. Then someone else will then smugly say, well, we're seeing pixels. Yes, you are. You're seeing pixels, but you're still wrong. We keep going. Well, you're seeing rays of light that are emanating from these pixels that are approximating the color of the thing at that pixel location using a combination of red light, green light, and blue light. And you're getting really close. And then you can go even deeper. And what we're really seeing are retinal stimulations that are being sent down our optic nerve and processed by our visual cortex that are eventually being interpreted as a representation that is a dinosaur. Now that's a long way down the rabbit hole, but the whole point of this is that this is not a dinosaur. But you knew that. This is not a dinosaur, but we treat it as though it is a dinosaur. And that is the fundamental nature of data itself. All data we collect is a representation of something. It could be something as abstract as a mathematical model, but it is a representation of something. It could be as concrete as a 3D scan of a statue or an engine part or something like that, but it's still a representation of something else. And data is often treated symbolically as the thing that is representing. And that's a useful thing to do. It's useful to take students into a museum and show them this and say, hey, this thing here, it's a dinosaur. And they're amazed. Even though it is so many levels removed from actually being a dinosaur, we still symbolically treat it as it is. And that is a convenient and useful tool. But when dealing with data, you need to understand that your data is never the thing that you're studying. It's only a representation of the thing that you're studying. And with that representation comes limitations. Every layer of abstraction that you're taking away from the thing that data is representing adds more wiggle room, more error, more ambiguity. So you always have to keep this in mind when doing data analyses, that the way your data was acquired, the way it was modeled, is going to fundamentally separate it from the thing that you're trying to analyze or measure or better understand. That doesn't mean it's not useful. You just need to understand that the representation isn't the same as the thing that you're studying. So for the purposes of this class, the definition of data that we're going to be using is an indirect representation of something else. Something else is ambiguous, and that's okay. But data is a representation of something else. It is an indirect representation of something else. Now, one of the cool things about data is that if you can collect data on something, it allows you to see elements of the universe that you were not capable of seeing before. It literally, in some ways, expands our senses. And you're going to get a lot of really dorky sci-fi references over the course of this semester. As a matter of fact, I have a full half lecture on Farscape, which most of you have probably never heard of. We'll get to that at the end of the semester, though. So here is step 2. Actually, we've already been introduced to my Star Trek joke earlier, but here is our next representation of how data science and sci-fi relate together. So I'm going to go ahead and spoil something important from Battlestar Galactica for you. That guy, he's not a guy. He is actually a robot of sorts. It's simpler to refer to him as a robot. So he's synthetic. He's not a human being, even though he looks like a human being. But he realizes something. As not being a human, as being a machine, he should be capable of doing things humans aren't capable of doing. I'm a computer. I can take in data from a bunch of different sources. I can see things humans couldn't see, but yet he is frustrated because the person who designed him in such a way that he is made to mimic being a human. He sees our visual spectrum. He feels warmth the same way we do. But that's not what he's not satisfied with this. That's not what he wants. He wants to see gamma rays. He wants to hear X-rays. He wants to smell dark matter. And he's angry because he knows as a machine he's capable of doing this. He knows that he can get access to that data and interpret it as sensation. Well, in many ways, this is what data science and data in general can do for us. It can expand our senses to see things that we're not capable of seeing otherwise. It expands our vision. It expands our senses. In other words, if you can detect something, if you can collect data on something, we can see it. By the way, I really love this picture here. It's one of my favorites. For instance, we can see things like this. This is these are real, actual atomic bonds. Photons can't see this. Yet we're able to visualize it and see it. This is real. This isn't a model. This isn't a simulation. These are images that were collected using an atomic force microscope. Literally detecting the force of one atom pushing against another atom. And using that, we can see firsthand, sort of, subatomic particles. Well, maybe not subatomic particles, molecules. We can see atomic bonds. We can also see things that are larger and older than we could possibly imagine. For instance, we've got nifty giant laser interferometers located at different places on the planet that we can use to detect gravitational waves in space. As a matter of fact, one of the physicists here, at our university was involved in the first detection of gravitational waves. So we can detect things larger and invisible. We can detect and visualize, actually see the compressing and stretching of space using collection of data. We can also let you see things that have no physical shape at all. If you've opened up any psychology textbook at all, at some point you've probably seen a picture that looks like this. This is called an equal loudness curve. And it's a representation of how sensitive you are to different frequencies of noise. This isn't some physical representation of anything. This is a visual representation of how your brain perceives stuff. And as a matter of fact, this is me. This is really, genuinely, truly me. And you can even kind of tell that, at around, the 125 hertz range, I'm losing a little bit of hearing, which totally works with what my wife has told me, that I'm going deaf, which I always respond to her as a, what? Yes, see, that's a joke. It plays better in person, so, you can even visualize quantum physics. You can do this in your home with aluminum foil and a laser pointer if you want. Visualizing interference bands. This is one of the first experiments, that shows the sort of bizarre nature of quantum mechanics. But what a lot of our data science is used for is this: tailoring advertising for you, the user. And these two are real, actual advertisements that I have been directed to. And which is really weird. Some of them are almost creepy accurate. For instance, I do use Harry's razors. Well, that was before I had the beard anyway. And I do love some good smoked sausage. I use contact lenses. I was looking for birthday gifts for my wife, one of which was a cell phone cover. I don't know why the tragic photos thing came up there. That's a little morbid. I mean, I've got a dark sense of humor, but maybe not that dark. And I was looking for a battery at AutoZone while this was going on, and I do shop at Kroger. Well, at least I used to, before, pandemic. I still order food from there, but, I don't really go in anymore. Oh, sad times, sad times. Now, there are a lot of different places that data science can be applied. Tons. But this is one of the places we're seeing it used most frequently these days. So I'm going to cut our lecture here, and we'll pick back up on this a little bit later, where I'm going to start by apologizing to our Python programmers. our little introduction to Python is going to be very bootstrap. It's going to hit the ground running. It's not going to focus on best practices. It's going to focus on getting stuff working as quickly as possible. So with that, I can hear my cell phone buzzing, which is the indicator that it's probably time for me to get downstairs and help with the baby. But that's fortunate because, well, we're at the end of today's material anyway. So anyway, folks, study the material we presented today. Our first quiz, I'm going to be posting that on Blackboard before too long, and it's going to focus primarily on some of the non-syllabus topics that we talked about today, along with some of the topics we're going to cover in our next lecture. So, having said that, stay happy, stay healthy, and stay safe. And see you in cyberspace, folks.